So this is a short discussion on the Radix sort algorithm, and this algorithm it can sort. It's for a specific type of sequence of elements. So we can sort integers or we can sort strings. So we're sorting objects that consist of a sequence of individual characters, like integers are digits and strings are characters from the keyboard. So today I'm just going to show you how to use Radix sort to sort a list of integers. But you can easily extend this. Let's say you had strings all lowercase or all uppercase characters. You can easily extend it. So instead of having digits 0 through 9, you'd have the letters A through Z, like an A would be 1 and Z would be 26. Okay, so in this case, yeah, so we're going to sort a collection of integer values. And so it's going to be kind of counterintuitive. So like if I was going to sort, if you give me a bunch of numbers and say, hey, let's sort these integers, I would look at the most significant digit, the leftmost digit, and determine its place. But here, we're actually going to start, we're going to go the other way. We're going to start at the least significant digit and then sort by the least significant digit. And then we're going to, and then the first sort by the numbers in the ones place. Then we're going to sort by the numbers in the tens place. And then we're going to sort by numbers in the hundreds place, etc. But it's got to be done in a certain way. So what we're going to do is we're going to sort all the numbers, let's say by the ones place, and then we're going to write over the original array. So we're just going to reorder the integer. So we have this collection of integers, like a array of integers, and then we're going to rearrange the numbers so that all the numbers are sorted by the digits in the ones place. So that way, all the numbers, all like the zeros, would be before the ones. If we're just looking at if all we're considering the numbers in the ones place, we'd see the zeros first, and then the ones, and then the twos, etc. Okay, and then you'll sort by the digits in the in the tens place. So let's etc. And then let's go look at the details. Okay, so how many iterations? The iterations depends on the maximum number of digits in the array. So like in this case, for this example right here, because it's a little bit bigger, this is online. It's 5,024, and so there's 4 digits, and so that's the integer with the maximum number of digits, and so there's going to be 4 iterations. Okay, so like 100 has 3 digits, but 3 has 1, 17 has 2. But in this case, so the maximum number of iterations, or the required number of iterations, equals to the maximum number of digits in an integer. Okay, so okay, so I think it'll just be easier just to look at an example, then we'll look at the code. And the actual code is, I think, online. Okay, so let's look at this array here, and we see here, so 1003 and 1001 have 4 digits. So the maximum number of digits we see in a particular integer, an individual integer, is 4. So it's going to take 4 iterations to sort this. Okay, so for numbers that have less than 4 digits, we just pad on the left with 0. So like 53 is really 0053, or like 105 is 0105, etc. Okay, so first let's just sort by digits in the one place. And so what we're going to do is we're going to create these what are called buckets. We're going to have an array of buckets. And so in this case, a bucket is going to be an array list object. So it's just, so an array list essentially is like an infinite size array. You keep adding to it. There's no reason why a bucket couldn't also be a linked list. But right now, so we're going to use the built-in array list, and we're going to have 10 of them. And we're going to have, so one of the buckets will hold the numbers that have 0 in the ones place, then a bucket just dedicated to holding the numbers with the ones place. So we're just going to go, we're going to loop through the array. We're going to loop through the array, and then we're just going to inspect the number in the ones place. So we just take the modulus with respect to 10, and we put it, and then we add it to that. But the array list class has a method called add. Okay, so we just add it to the array list. So we copy the and then, so this is part A. First, we copy the array. We copy every element into we assign every element in the array to a bucket, either to bucket 0, 1 through all the way through 9, all depending on the number in the ones place. And then we copy the contents of the buckets back to ARR. We're writing back over ARR, and we do it in sequential order. So first start with bucket 0, then start with bucket 1, and then start with bucket 2. So that way, so when you're done with part B, all the array will now be ordered. If all we consider was the number in the ones place, the array would be ordered or sorted. Yeah, sorted in proper order. Okay, so let's just look at this. Let's just look at, let's just see this. So we actually have this. So yeah, I can't actually, unfortunately, I can't keep all the the original numbers on the and the buckets on the screen at the same time. So okay, but yeah, so but you see here we have, so like 10, 10, 510. I think those are the only two that end in zero. Okay, so 10 and 510 would be put in bucket zero. And 10 would be, we're going to start from position zero, like the 108. So the first number we come to 10 before 510. So 10 would appear in the bucket before 510. And then like what would be in, are there any that end in one here? Yeah, like 1001 ends in one and 21 ends in one. So 21 and 1001 would be in bucket one. So let's just go down here. Yeah, and that's what you can see here. 10 and 510 are in bucket zero, 21 and 1001 are in bucket one, and so forth. So you look at the bucket number, yeah, and you see all so the numbers that, so if you look at a bucket number, the numbers in that bucket must have the same number in the ones place. Like bucket 7 has 117. Okay, so now what we're going to do is we're going to copy over the original rate, and it's critical. It's absolutely critical that we start with bucket 0, right? So, and then we do bucket 1 and bucket 2. So now just look at the numbers in the very last digit. See 0, 0, 1, 1, 2, 3, 3, 3, 4, 4, 5. We see that, yeah, so we see, if all we cared about was the number in the ones place, it's sorted. Of course, it's not a sorted array because 243 is like here. 243 is actually greater than 53. But if all we look at the numbers in the ones place, we have 3, 3, they're equal. Okay, so okay, here, so let's continue to proceed. And now what we're going to do, we're going to clear all the buckets, right? So you don't want to keep 5, 10, and 510 in bucket 0, because then when you start, see, the next thing we're going to do is we're going to look at numbers in the tens place. So like, what would go in bucket 0 in the tens place? So 1001. It's hard for me to print it right on the screen. So 1001, 302, 1003, 105. Yeah, so a bunch of them, 108. Okay, so before we put those numbers into bucket 0, we have to get rid of 10 and 510 because we don't want it, because otherwise we're going to double the size of the array for every iteration. So we empty the buckets, so we get rid of all the data in the buckets, and then we start putting these new values in. But the important thing is that we started, see how the array is sorted by the numbers in the ones place. We have to start. So when we put numbers in the buckets, the important thing is that we go in this kind of sequential order. First, we start with 10 and 510, and so forth. Because look what happens here. So let's say here. So because now if we look at numbers in the, so let's look at the numbers that have a 0 have a 0 in the tens place. So let's just go in order here. So it's 1001, right? And so then 302, but see, 1001 but the 1001 is going to be before 302 in the array because it's already sorted by numbers in the ones place. So 01 is going to be before 02. So now when we put 1001 and 302 in bucket 0, 1001 will be put in before 302, which will be put in before 1003, be put in before 105, and so forth. So we start putting numbers into the buckets by the numbers in the tens place. They will be ordered by the last two digits, by the numbers in the by the last two digits. The numbers in the, we just look at the last two digits, it will be sorted. So every bucket will actually be sorted by the numbers in the last two places, and then we copy it back into the array, and then the entire array will be sorted by the numbers in the last two places. It's really, really kind of clever. And you do that 4 times, and then the array is sorted. Okay, but let's see what happens here. Okay, so now we're going to sort by numbers in the tens place. So we divide a number by a 10. Okay, so that gets rid of the number in the ones place, and then we take the modulus with respect to 10. So this expression right here gets the number in the tens place. So we assign it to that bucket. So now we're assigning numbers to bucket based on the value in the tens place. So you can see right here are the numbers in the ones place, and see how it's sorted by the last two digits, 1001, 302, 1,000, 3, and so forth. The numbers in the ones place, see it's 10, 10, 14, 17. And then the four has a 43 and a 44, and the other ones just have one, either 0 or 1 integer. And now we copy back over into the array. And when you do, and you start up, you have to, if you don't start at bucket 0, then, if you just start randomly at any bucket, it won't work. You have to start with bucket 0, then 1 and 2. And now when you do that, see the numbers are now ordered by the last 2 digits, 0, 1, 0, 2, 0, 3, 0, 5, 0, 8. And so forth, right? 53, 76, 85. And now we have to just do this 2 more steps. So just put these numbers into the buckets by using the number in the hundreds place. But again, you have to clear the buckets, right? So like we don't want 21 in bucket 2, right? Okay, because we're going to look at, well, first of all, the 21 is 0, 2, 1. So when we're assigning numbers to buckets, for the third iteration, 0, 2, 1 would go into bucket 0. So any 2-digit number is going to go into bucket 0 for the third iteration, for the numbers in the hundreds place. Okay, so we divide by 100. That gets rid of the last 2 digits. And then we take the mods with respect to 10. So that's how we get the number in the hundreds place. And so now, and then, so we get all these buckets. And see, if you look at the last 3 digits, it's 10 is 0, 1, 0. 21 is 0, 2, 1. You see it's ordered by the last 3 digits. You see 105, 108, 109, 117. And again, you copy back over to the array. So after the third iteration, it's ordered by the last 3 digits. Okay, and so now the very last, I know suspense is killing us here. What's going to happen after the fourth iteration? Fourth iteration, we're going to sort or sort by digits in the thousands place. So this will get rid of the last 3 digits, divide by 1,000, and take the mods with respect to 10. You'll get the number in the thousands place, and then you copy the contents into the bucket. So most of these numbers will go in bucket 0. Because if you remember, if you go back to the original array up here, I'm getting dizzy just doing this, going up and down the PowerPoint slide. But you remember the original array, there were only 2 numbers that had 4 digits, 1,003 and 1,001. All the other ones had 3 or less. So remember, so for the like 108 would be really 0, 108. So most of those will actually have a 0 in the thousands place. So for the very last iteration, most of the numbers will be in bucket 0. So any number, let's see, let me go down right here. So any number with 3 digits or less will go in bucket 0. So all those numbers in bucket 0 are ordered. And then in bucket 1, we have 1,001 and 1,003. And it's actually ordered, right? So the numbers in bucket 0 are ordered. And we're looking at number, and now we're looking at, so now it's ordered by numbers in the thousands place. And that's the highest, that's the most significant digit of all. So if you look at the numbers in bucket 0 and bucket 1, collectively, they're ordered, and we write back over into the original array, and now you have an ordered array, okay, in increasing order. Okay, so it's pretty wild, students. Okay, so someone told me that, not someone told me, like who would tell me this? I think I once read that, like, you go to train stations and you're seeing the arrival times and those things, that those like cards are flipping really fast. Someone told me that they use Radix Sort, but I once went to a train. I mean, I've been in train stations a couple of times. I try to see, like, it just goes so fast. I can't really tell what they're doing. Okay, so anyway, okay, so let's just kind of, we'll look at the code, I guess. I'm gonna have to open Eclipse. Okay, so let's look at the algorithm for an array of non-negative integers. And so we allocate memory for 10 buckets. Each bucket is represented by an array list of integers. Okay, so you find the maximum number of digits in the list of integers, and then we loop, so the number of iterations is equal to the maximum number of digits, and yes, and then you subdivide. You divide the array into buckets using the digits in the place POW. So originally POW is 1, first we put all the numbers into the buckets, and then we empty the buckets right there for bucket number 0 to all the way up to, oh, this should say less than, I never noticed, it should be less than or equal to 9. So, or bucket number, 0, it should be bucket number less than or equal to 9. And then bucket number plus, we copy the buckets back into the array, and then we increase then power just gets multiplied by 10. So the next time around, you're looking at numbers in the tens place. And of course, and when you copy the contents of the bucket back into the array, you need to empty the bucket. So with the array list class actually has a method called clear. So after every iteration, we clear the buckets. Okay, so let me just say one last thing here. So suppose the list includes negative numbers. Okay, so if you did the radix sort, it would be sorted by absolute value, but it wouldn't really be sorted. You get 4, -8, 9. But the magnet, it's ordered by magnitude. So how do we? So here's just one kind of way of doing this. Okay, so after you get it ordered, let's say you had negative numbers, and so you get it ordered by magnitude. And now what we do is we want to rearrange these values so the negative numbers go on left, and the biggest negative number goes all the way to the left. Okay, so notice that the biggest negative, the negative numbers will be in will be in order of magnitude. So the smallest negative number will be like negative 8 comes before negative 23 because the absolute value of 8 is less than negative 23. So if we keep putting the negative numbers on the left, by the time we're done, we'll actually have a sorted array. Okay, so so when you put numbers in the bucket, so just use the absolute value. Use the absolute value in computing a bucket number. Also, you could get a negative bucket because the modulus operator does give you negative values. Okay, and so then you sort, the array with the radix sort algorithm, and you'll get, it'll be sorted in by magnitude. And now we want to move the negative numbers to the left. So we're going to use one of the array is sorted by absolute value by magnitude. And so we're going to use one of the buckets. So just make sure bucket 0 is empty. And what we're going to do is we're going to copy the array. We're going to use bucket 1 to kind of move positive elements to the right and negative elements to the left. So so we're going to iterate through the array. If the array element is greater than or equal to 0, we add ARR at the end of bucket 0. So the add method in the array list always moves a value, adds at the end of the array list. Okay, and if ARR value is negative, we're going to add ARI at position 0. So remember, there's actually this overloaded add method for the array list class. We're going to put a position 0. So that means we go directly to the left. All right, so first like negative 8, here we have like a bunch of numbers. Negative 8 would go to the left, and then we get to negative 23, and negative 23 would be to the left of negative 8. So this would actually sort the array. And then when you're done, you just copy the contents of bucket 0 back into the array. So why don't we just look at a couple of problems here, then maybe we'll look at the code. Okay, so here I kind of don't like these method names. I got this out of a book, but I don't really like these method. Everything get should be first. Okay, radix get length. Okay, so you just want, basically all it's saying is, or what's the here for B would be 5 because 1003, it has the most integers. And like for C, 456 has 3. Okay, so let's consider the list of integers right here. Okay, so, and I'll do a couple of these and then we'll look at the typed value, and we'll type solution file. So when placing integers into the ones digit, when placing integers using the ones digit, what integer will be in bucket 8? Okay, so all we have to do is look at all the numbers that end in 8. So it'd be 9, 7, 8. It's a pretty straightforward problem. Of course, I can't print, so that doesn't help. So it would be 9, 7, 8. What else would be there? I think that's it. No, 1008. And that's it. Oh, and 48. So for all we care about are numbers in the ones place, then these numbers are actually equal. If we're just going to ignore everything in the tenth and above place, they all have a 8 in the ones place. And so those would all be in bucket number 8, where we're ordering by numbers in the ones place. And so, okay, so let's look at B here. I mean, B, this one right here. When using integers using the tens digit, what integers will be in bucket 0? And so we're going to actually make sure the numbers are listed in the order generated by the radix algorithm. Okay, so we want to make sure that the numbers are ordered. Okay, so just by the last 2 digits in bucket 0. So we're going to so first of all, we're going to look at numbers. We're going to consider all the numbers that have 0 in the tens place. And so, and they're going to make sure that they're ordered. So like 1005 would become before 1009. So let's just first of all let's just identify the numbers in, okay, so 309, 1005, 204, 1008, 103, 504, and 2000, no, not 2076, that's it. Okay, so let's just go down right here. And okay, so which is the, so 200, so I think 103 is the smallest. And all we're doing is the last two digits. I don't care about that one. And I don't care that it's 103. I just care that it's 03. And that comes before. Now look at, there's 204 and 504. Which one comes first? They both end in 04. Well, you want to go, so you use the one that you encounter first as you go from left to right. If the last two numbers are the same. So 204, 504. And then what else is there? There's 1005, I think. And 309. So that's, so 1, 2, 3, 4, 5, 6. Yeah, so, oh, I feel like I'm missing one here. Okay, so 309, 1005, 204. Oh, and then we need 1008, and then 309. And then well, continued. Okay, so there'd be 6 numbers, and this is how, yeah, so it's 0, 3, 0, 4, 0, 4, and again, 204 before 504, because, yeah, because you would, because you're putting numbers in buckets as you read from left to right. So we would read 204 before 504, just because that's how it appears in the array. And then, first of all, 204 would go in bucket 4 first. And we're ordering first by the ones place. So 204 would become before 504, go into bucket 4. We're ordering by the ones place. So then when you're copying back out into the array, the 204 would be before 504 in the array. Okay, so then, and then 1005, 05, 08, and then 09. So it's ordered just by the last 2 digits. Okay, so let's just look at this last interesting problem here. Write out the contents of the array after sorting using the numbers in the least 3 significant digits. These problems really aren't too hard if you, most students get it right. Occasionally, students get these kind of problems wrong. Maybe they just either rushing or they haven't read the problem very carefully. Okay, so let's just look at the solution file just so I don't make errors. So now write out the contents of the array after sorting using numbers in the least 3 significant digits. And that's the digits in the last 3 places. So look, so look here, the numbers, yeah, so we're looking at the numbers in the, so 1005, 1008, so 9 is 009. We're looking at the last 3 places, 011, 042, 048. So if you, so 076, 081, and a lot of, yeah, so then we get to the ones, 103, 167. So you can see that it's, we don't care about, now is it actually sorted? No, because 1005 and 2076 would actually go away at the end if we were actually sorting by all 4 digits. So they're just sorted by the last 3 digits. And this, so basically we're just gradually sorting this way here. So let me see if I can open Eclipse. Should have had it open up earlier. Let's see if I can actually find the, I'm going to stop sharing just for a second here. Oh, hello. So I'm going to stop sharing and then make sure that Eclipse, they don't have any student files open. I should have had this done before. Now here's Radix Sort. Okay, so I'm going to go back to sharing. Hello, back to sharing here. Okay, so. Okay, so there is the code for Radix Sort. And then, okay, so yeah, so we have, first of all, we have a method, just you'll get Radix get length. So that finds the number of digits in an individual integer, right? You start line 20, you start digits at 0. And what you do is you just keep dividing this number by 10 until you get 0. Right? Every time you divide it by a number in 10, you get rid of the number in the ones place. And so basically it's just counting so the number of digits in value, we just keep dividing by 10 until value is 0. And basically we're counting the number of iterations. So get radix, get max length. We're finding the individual integer. It's like finding the largest in this case. We're not going largest by absolute the size of the integer, but the largest by the maximum number of digits. Okay, so then there's a radix sort. Now this is the famous radix sort. Okay, so look there on line 32, and this code is on line 32. We create this array of integers, and so really common error. So that bucket array, it's an array of objects. So remember, every array element has a default value, and the default value for an array of objects is null. So there on line 35, we actually have to allocate memory for every individual element in the bucket array. So that's a really common error, especially when we're first starting out programming. We allocate an array of objects, but then we don't allocate memory for each individual object. So a loop like 35 is absolutely critical when you're dealing with arrays of objects. Okay, so then you get the maximum number. We find out 40. We find out the maximum number of, we find out the number of iterations by finding the length of the maximum number of digits in one of the integers, and that's how. And then on line 43, we start looping, right? First, we start digit at 0, and then and so the pow 10 starts at 1. That's the power of 10. And so the first time we'll assign to buckets by the number in the ones place. Yes, we take a number there in line 45, take a number divided by 10, and then modulus 10. That gives us the number in the ones place. Line 46, we add it to the bucket, and then starting from line 48. Starting in line 48, we start. We're going to read. So we loop from 0 to I less than 10. I think in the notes I had I less than 9. I less than 10. So we loop over all the buckets, and so that inner loop 40 loops through an entire bucket, right? We loop through bucket I, and every bucket it's an array list. So it actually has a size method. So we loop through the bucket, and we just get the value. We get a value out of the bucket, right, with the get method, and we copy it into the array. So we actually have that. Okay, so we actually have to have we have to declare some kind of variable to say what index to put in the array. So we start array indexing 0. So every time we copy into the array, we increase array index by 1. And then when you're done, and then after we're done with the bucket, we clear it. So line 48, that gets rid of the contents. So we're ready. So we have an empty bucket. So when we start ordering by numbers in the ones place. So the loop at 44 assigns the array elements to the buckets, and then we use the buckets to copy over the array. So after the first iteration, it'll be ordered by numbers in the ones place, then ordered by numbers in the tens place. And by the time you're done, the whole array will be ordered. And then here is what I'm talking about here, just in case you have negative values. So there at line 68, I just can take care of the case where you have negative values. Okay, so let's just run this and see what happens. So all the numbers just have 2 digits. It's not the most exciting thing, but you can see it. So let's see here. So we call radix sort, and then the numbers are ordered. All right, so